Assalamu alaikum students. Today's lecture is about amino acids, peptides and proteins. Amino acids are building blocks of proteins, and multiple amino acids join together to form peptides, and peptides assemble together to form different proteins. In this lecture, proteins are the basis of life on earth. So in this lecture we will detail out the structures, compositions and chemical reactions of all these molecules. Let's begin. Amino acids are alpha amino carboxylic acids. Alpha amino carboxylic acid. This carbon, the carbon next to the carboxylic group, this is carboxylic functional carbon. Carbon next to carboxylic functional group is called, this carbon is called alpha carbon, and amino group is linked to the alpha carbon. That's why these are alpha amino carboxylic acids. The building blocks from which proteins are made, except for glycine, R is H. When the amino acid is glycine, the R is H. Here, instead of any carbon chain, there is only H, hydrogen bond. All amino acids are chiral molecules. There are 20 natural occurring R groups. We will discuss all of them, most of them, in this lecture. As with the carbohydrates, it is traditional to use the D and L nomenclature with amino acids based on the configuration of glyceraldehyde. Same in case of carbohydrates, we use D isomers, L isomers. Here, in case of proteins, we also use D or L kind of configuration. Naturally occurring amino acids generally have the same configuration as L-glyceraldehyde. Remember, all the bulky groups are on the right side of the carbon. That's why they are written as L, and naturally occurring amino acids are written as such. Carboxylic acid CH3 is written as such, and the L-glyceraldehyde in this form, all OH is on this side. This is also L-glyceraldehyde. This is structure for L-alanine when this R is replaced by CH3. This is the next simplest from glycine, next simplest amino acid from glycine. And in this glycine, this is the structure of glyceraldehyde. This is not the amino acid. You remember, in case of fatty acids or lipids, we talked about glycerol. Glycerol is 3 carbon, 1, 2, 3, and then there is OH, OH, OH here. But here this is OH, and there is aldehyde functional group here, and this OH is on the other side, left side, and this is L-glyceraldehyde this way. So this is the aldehyde functional group, not the amino acid. Amino acids, they bear acid-based properties. They can be treated as acids. They can be called bases because they are amphoteric compounds due to the zwitterions on them. Since amino acids have both an acidic functionality, carboxylic group, acidic functionality, and a basic functionality, we should expect the following equilibria. In water, they can be rearranged as such. In fact, the equilibrium lies to the right. All amino acids are charged at any pH. Amino acids, they are in this form, in this zwitterion form. Such species that are overall neutral molecules but contain charged ions are called zwitterions. You should remember them, and you should know the structure. Acid-based properties, amino acids can react as either acids or bases. This is the charge structure of amino acids, and when they are treated with hydrogen plus ions, hydrogen is added at the carboxylic end, they are acids. And when they are treated with base, with they are put in the hydroxyl media, they react as the NH2 that is more evident. This basic character is more evident. Acid-base properties. Amino acids can also have side chain containing acidic or basic groups. Deprotonated at physiological pH, glutamic acid is acidic R. This is the structure for the amino acid, alpha amino carboxylic acid, and this chain can be R. But in this case, you see there is extra COO2 in this R. So this is acidic R, and this is glutamic acid. Its name is glutamic acid. This is the kind of amino acid that is acidic in nature because it is bearing 2 carboxylic groups. And when it is protonated at this is deprotonated form, and when it is protonated, it when there is another form of amino acid, deprotonated amino acid. Deprotonated amino acid, its name is lysine. This is having a carbon chain that is having amino functional group at the end. So they are acidic and basic. Two types of amino acids, acidic and basic. Amino acids are classified on the basis of the structure of R: aliphatic side chain, hydrophobic, polar side chain. Aliphatic side chain, when R is all together CH2, CH3 without any functional group, and these are polar side chain amino acids. When a side chain, it contains OH as amide, and they can be acidic as we have seen in the last slide, and basic as well, and they can be heterocyclic. R structure can be heterocyclic as well. Amino acids are classified on the basis of the structure of R: aliphatic side chain, that can be hydrophobic, and these are the structures of different amino acids. Glycine, this is the simplest amino acid where R is H. Alanine, where R is CH3, and valine, leucine, and leucine. Right here, there is aliphatic side chain or hydrophobic side chain in these two. In these three here, this is also aliphatic side chain, but these are the complex or lengthy hydrophobic chains.